This is Sung, and I'm the Principal and Director of Sky Academy, and I guess the first thing I want to do is welcome you back, okay? Today what we're going to be doing is studying a brand new topic, okay? And the brand new topic is actually a continuation of a prior topic that we did before. So remember before we did a topic called Indices and Logarithms? Well, this topic is an extension of that. It is the topic of exponential and logarithmic functions. And exponential and logarithmic functions, the difference between this chapter and the previous chapter that we did in the past on indices and logarithms is that this chapter, okay, uses all the knowledge that we did prior and applies the work that we did on calculus to indices and logarithms. So we have indices and logarithms over here. We've done all the chapters that we've done on calculus, geometrical applications of calculus, differentiation, integration. And what we're going to be doing is all that work that we did on calculus, we're going to marry that and apply it to indices and logarithms. Okay, so let me give you a quick recap of the indices and logarithms chapter. Right, this will tell you where the gaps are in your knowledge, and if you need to, it would be a good idea for you to go back to the episode that I did in indices and logarithms, just so that you can get a recap, a refresher on the individual teaching points that get covered here that you have weaknesses with. Okay, so for example, we did the index laws, which look like that. Okay, we did the log laws, which look like that, and we realized that indices and logs, or the index log forms, are basically two ways of writing the same thing. All right, the index form is written like this: y is equal to a to the power of x, where you've got a base, an index, and an exponential result. Rearrange that, put it in a bag, shake it up, and then basically what you have is the logarithmic form, which is x is equal to log a to the y, where a is your base, y is your exponential log, and the log represents an unknown power, which is your index, okay, which is x, right? So we looked at the logarithmic form, the index form, we looked at the laws governing them, and we got familiar with that, okay? We also looked at the graphs, all right, of indices and logarithms, okay? But just before we do that, we also did the change of base law, okay? So if we want to change the base of a logarithmic form from log xy to a different base, say to the base a, then what we realize is that these two numbers to the log of a new base, right, will be equal to the log of the previous thing if we divide one into the other, okay? So this is what we call the change of base law. All right. Now, the important thing that you need to be aware of as we move forward to the new topic of exponential and logarithmic functions is what exponential and logarithmic functions look like, and we touched upon it in our previous work. But what we realized is that exponential and logarithmic functions are what we call inverse functions of one another, all right? So in other words, they're mirror images of one another, all right, about the line y is equal to x. So if you've got an imaginary line, y is equal to x, and you folded one function over onto the other function, then they would be mirror images of each other. Do you see that? So in this, for the logarithmic curve, it passes through the point 1, 0. Do you see that? In the mirror image version, it will pass the y-axis, not the x-axis, at 0, 1. All right, so they're mirror images of one another. That's called an inverse function, and that's what we call inverse functions. They're inverse functions of one another, and they are reflections about the y-axis. What we're going to do in the next chapter is we're going to look at exponential functions in particular, all right? Or we're going to start with looking at exponential functions in particular, and look at what will happen when we differentiate that. In other words, find the gradient of this curve along various points. Okay, so that's what our first episode will be in the next unit. But what I wanted to do is to get you to really understand and be familiar with, right? What the work that we did with indices and logarithms. So it was worthwhile doing a recap of that so that if you have any gaps in your knowledge or if you're weak in a particular area of this summary, go back, watch those summary units, and I'll look forward to seeing you on the next episode of exponential and logarithmic functions, where we will look at the gradient of the tangent along the curve y is equal to a of x, a to the power of x. And I look forward to working with you as we apply calculus to the exponential and logarithmic functions. It's going to be a fun ride, so I look forward to being with you. Thank you very much for watching. I'll talk to you soon. Bye.